Hey geometry class, welcome to the new unit on circles. We're going to talk about everything we can regarding circles that we haven't talked about yet. So we're going to talk about tangent lines and chords and arcs, inscribed angles, angle measure segments, circles in a coordinate plane, what a locus is, which is how we probably should have started the entire year. But there's a lot to go over in this unit, and we're going to begin with tangent lines. So this will probably be another 3 video segment, and we're going to talk about identifying a tangent and talk about angle measures and how tangents work. So this whole lesson is about tangents. So let's start talking about tangents, shall we? Yes. So you got to figure out what in the world is a tangent. We don't really talk too much about that in the definition. All we say is, hey, if there is a line tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So there's a lot going on here that we haven't even discussed yet. So we got to talk about remember what a circle is, a set of all points equidistant from a fixed point. And then we remember what a line is. The line is tangent to the circle if it touches only at one point. So that's a key element of the vocabulary. A tangent is a line that is crossing, interesting, although it's touching, crossing a circle at only one point. And that is what a tangent is. It crosses a circle only at one point. And if that is the case, it's going to be perpendicular to the radius. Okay, so if the line is tangent to a circle, it's going to be perpendicular to the radius. All of these notes really talk about that. So we got to know what a tangent is. A line crossing a circle at only one point. Now what happens if something goes through a circle? That's called a secant. Okay, so if a line goes through a circle, that's called a secant, where it crosses at 2 points. And then if that is the case, then you have a chord, which we'll talk about later in the unit. And the chord is a piece of a secant that is inside the circle. But those are the other things. But right now, we're really talking about a tangent. So let's discuss the whole situation with tangents, shall we? Let's take a look at some examples of learning tangent. So let's start with, how do we identify a tangent? So in this given diagram, we're telling you that, or we're asking, is ML, this segment here, is ML tangent to circle N at this point L? Is it tangent? That's the question. Well, how are we going to know? Well, remember, if it were tangent, it would be perpendicular to the radius. So really, the question is line ML perpendicular to the radius? That's the question. So this is indeed the question. Is that the case, that that line is tangent to ML? So when we're looking at this diagram, what exactly are we looking at? The question is, are we looking at a right triangle? Is this a right triangle? And if it is, then we know that ML is tangent to the circle at L, because it would be then perpendicular to the radius. We have to make sure we understand that. Okay, so it goes back to the vocabulary, making sure that we understand what perpendicular means and how we can make a right triangle out of that situation. Right, so that's perpendicular. So is ML, right, this line here, is that going to be tangent to the circle? Well, how are we going to figure out if this is a right triangle? Remember our good friend Pythagoras. Okay, so we have to work on the Pythagorean theorem. And if you remember your Pythagorean triples, this will make life a whole lot easier. But if not, remember how this works. The sum of the squares of the legs is equal to the square of the hypotenuse. So the question is 7 squared plus 24 squared equal to 25 squared? That's the question. Okay, so that is exactly what we're asking here. Is that the case? And so the rest is, calculator work and figuring some stuff out. So of course 7 squared is 49, and 24 squared is a bigger number, 576. So is that 25 squared, which is 625? Okay, so we add up 49 and 576, and we realize, no, wait a minute, yes, that is 625, and that is 625. So we have a Pythagorean triple on our hand. And now we know with Pythagorean triple, we have a right triangle. And since we have a right triangle, we have a right angle. And since we have a right angle, we have perpendicular. And since we have perpendicular, we have tangent. Okay, so all this comes into play. So holy cow, is it tangent? Yes. And then what's the explanation? There it is, right? So when it says explain, dude, let my numbers do the work. Okay, so that's the explanation. So let's do another example real quick. Is, in this case, now a new diagram. Is this segment ML tangent to N and L? And then we're going to explain. So once again, is this a right angle? Do we have a right triangle on our hand? And so we're looking at our legs, which of course are 4 and 7. Is that equal to 8 squared? So 4 squared, 7 squared, is it equal to 8 squared? So do we know if 16 plus 49 is equal to 64? And the answer, of course, is no, because this is 65, this is 64. It's awfully close, but no, this is not a right triangle. If this is not a right triangle, then this is not a right angle. And if it's not a right angle, it is not perpendicular. And if it's not perpendicular, it's not tangent at the point. So no. No. And so explain. So we can explain ourselves that way. All right, so let's do a couple more examples when it comes to angle measures, and then we'll wrap this first video up, so we're getting used to things. I'm going to start with this question first in this diagram. Is segment ED, or actually we're not asking, ED is tangent to circle O, what is the value of x? Okay, so what is this saying? ED is indeed tangent to O. So what does that mean? That means it is perpendicular to the radius. And that means we have a triangle on our hands, in this case, a right triangle. So the question is, what then is the value of x? Well, we have a triangle. So guess what we know about triangles? We have interior angle measures at 180 degrees. So we can easily, I hope, easily solve for x, right? Because we know that 90 plus 38 plus whatever that angle is going to give us 180 degrees. So all we have to do is some basic algebra. Okay, so 128 plus x would be 180. And I'll show you a shortcut in a second. We subtract 128 from both sides, and we get 52. So the measure of x is 52 degrees. So, Mr. Katz, what was the shortcut you speak of? Well, when we're dealing with triangles, and if we have a right triangle, and we know that the right triangle is a 90-degree angle, then the other two angles must equal 90. Right? So if one angle is 90, the other two together must equal 90. So we could have easily done this. We could have said, well, just 90 minus 38. That's 52. Right? So we could have done it either way. Right? So no matter how we're doing it, we find the value of x is 52. Okay, so now for the hardest one for last. We'll save this one and call it a video. Here's another example. We're going to find this angle measure. What is the value of x? And again, we have two different ways of doing this. So it's telling us that ML and MN are tangent to circle O. So what does that mean? That means we have a right angle here and a right angle here. Now, two ways to approach this. Way number one is through a quadrilateral. If we view this entire diagram as a quadrilateral, we know that the interior angles are 360 degrees. All the interior angles add up to 60 degrees. So what this tells us is that if I add 117 plus 90, because it's a right angle, plus another 90, again, we know it's a right angle, plus our x is going to equal 360. And we can do algebra that way. Okay, so let's also do a calculator shortcut, and you guys can see what's going on. Let me scooch that up. So check it out. We have 117 plus 90 plus 90 equals. Okay, so we have 297. Now I'm going to subtract that from 360. So I can just say minus 360 and know that minus 360 and know if I can punch 360 in. I'm going to do the whole thing. I'm going to do this over again. Chubby fingers on that. All right, so 117 plus 90 is 180. Equals. I'm going to subtract that from 360, and I know it's going to be a positive number. All right, this is only negative 63, but I know it's a positive number, so I'm subtracting it from 360. So I know my answer is going to be 63. So that's what x is. Okay. So that's way number 1. Viewing it as a quadrilateral as long as you know how to use a calculator, unlike me. Now, there's a second way to view it. Not only as a quadrilateral, but 2 right triangles. How could we look at it 2 right triangles? We would have one right triangle at the top and another right triangle at the bottom. Okay. Now, this angle in here together is 117. But if we're looking at 2 triangles, we would have to split that 117 in half. So 117 divided by 2, that's 58.5. So if we're looking at 2 right triangles, we know this angle measure is 58.5. And we know this angle measure is 58.5. Okay, so we can look at 2 right triangles and look at just one triangle at a time, find the missing angle. Okay, so like we said before, if it's a right triangle, we know the other angle must be complementary. So it's 31.5. So this angle in here, 31.5, which is the same thing for this angle in here, 31.5. And what would be the total angle measure, which would give us x, right? That's the total angle measure. Notice how that's working. So if that's the case, we know, again, 31 and 5, 31 and 5, add them together, you get 63. So either way, you get x equals 63. And so that's how we're working with angle measures with tangents. So come back for the next installment, and we'll talk some more about tangents. See ya.